So this experiment is an SAYBOLT viscometer. So this is to determine the viscosity of given lubricating oil using SAYBOLT viscometer. So here this apparatus consists of an container. This you can see, this is being in a container. So inside this we are going to pour in a water, and here inside this we are going to, this is an topmost covering point. So inside this you can see that you are going to pour in a oil, for which you need to find out viscosity. So at the bottom you are going to have this hooper. So inside this you are going to have a small hole. From that, drop by drop the oil is been collected in this container. So and which is, after that, which is we are going to weigh that oil, how much it is been contained in a given temperature and in given time period. So here the viscosity is the measure of internal resistance of fluid to shear and indicating its relative resistance to flow. The absolute or dynamic viscosity is defined as a force required to move a flat surface of unit velocity when separated by oil of unit thickness. Kinematic viscosity is defined as a ratio of absolute viscosity to mass density. SAYBOLT viscometer generally applied for determining the viscosity of the given oil. It consists of standard cylindrical tube, and upper end of the tube is fitted with overflow cup, and the other it consists of standard outlet tube, which is of 1.76 mm diameter to 12.25 mm in length. Below this is a cork is fitted to prevent an oil flow through the outlet tube until it is being removed. So this why we want to find out the viscosity means, so to reduce the friction between moving parts, to minimize so that powerless reduces, to reduce the wear of moving parts, to provide cooling effect, to provide cushioning effect. Viscosity of lubricating oil at the time of starting of engine should be low. So otherwise engine may not start. While the engine is running, viscosity decreases due to increase in temperature. So now let us find out the procedure, how it is been carried out. So note down the mass of the 60 cubic centimeter empty flask. So we have been having a 60 cubic centimeter empty flask, and clean the oil tube, add the water to the water jacket. So this is where you have been pouring the water, and pour the given oil into the tube up to the mark indicator, ensuring that the rubber cork is closed position. So we have to close this rubber cork at this bottom, and after that we have to pour an oil here inside this one to the given mark, and insert two thermometer, one in the oil and other in the water. Here we have been having two ports where you are going to, so from this you are going to here have one thermometer been placed in this oil, another thermometer has been placed here to find the temperature of the water at this point, and to find the temperature for the oil. Means here oil means the lubricating oil what we have been using it. So after this, heat the water by means of electric heater. This has been heated by electric heater. We have been having this knob setter where you can change according to the requirement, and stir the water until the water and oil attains the thermal equilibrium at the given temperature. Start the stopwatch and note down the time taken for collecting 60 cubic centimeter of oil in the flask. Note down the mass of the flask within a oil. So repeat this experiment for different temperature of the oil. So here you are going to have a tabular column. You can see that for different temperature we are going to find out amount of 60 cubic centimeter of oil is been connected, and what is the time it is been taken, that we are going to note down here. Then you are going to have so empty cup weight and the weight of the oil which you have been collected. So based upon that you are going to have an equation. So based upon that you are going to find this density of the oil. So difference of the with the cubic 60 cubic centimeter what the oil it is being collected, and without the oil, so the temperature difference what you are sorry, the weight difference what you are going to get, that is going, you are going to note down. So from this equation you are going to find out the density of the oil. Then you are going to have this equation, kinematic viscosity. So based upon the seconds, you are going to identify which one you need to be selected. Then with this equation you are able to identify the kinematic viscosity. After you knowing the kinematic viscosity, you can easily find out the dynamic viscosity. So dynamic viscosity is kinematic viscosity multiplied with the density. So you are going to get this value. Then you are going to plot the graph with respect to dynamic viscosity with respect to temperature. You can see that as temperature increases, the viscosity goes on decreases. Okay, here different forms of oils we can use of different grades SE 5 watts and SE 10W, SE 20W, and SE 20 and SE 30.